we're going to look into a familiar topic from Algebra 1, the quadratic formula, and use it to solve our quadratic equations. We've already seen how to solve graphically and through factoring, but this method in particular is pretty handy because it will always find our solutions for us, whether they are real or imaginary, decimals or fractions. It's a foolproof method, and it's a good one to have. So hopefully by the end of this lesson, not only can we find solutions, but maybe even be able to tie in what we know into what we've done in the past with looking at the graphs of these quadratic functions. So let's go ahead and jump into looking at the formula here. You notice we're solving for x, which was always true. Our solutions on the graph are x-intercepts. And all we have to do is simply substitute values of a, b, and c. And those are the same values we've been talking about in your equation, the coefficients that we have. And so if we can put these in here and we can substitute, we're going to find our solutions. And if you remember, we always want to find two solutions, and that is why we see this plus or minus symbol within the formula. So if any of that looks confusing to you, just follow along, and pretty quickly we're going to clear this up. So some very simple steps. As before, we want our equations to always equal 0, and that guarantees that we are finding values on the x-axis. And once we have those equations equal to 0, we'll identify our values of a, b, and c. We'll substitute into the formula, and then it's just a simple bit of order of operations to simplify from there. So let's take a look at a couple examples here. Number 1, we have 2x squared minus x equals 4. Not ready to go yet because it is not equal to 0, but that is a quick fix. If we simply subtract 4 on each side of our equation, remember, you don't want to combine any unlike terms. So we have 2x squared minus x minus 4. And then on the right side, 4 minus 4 equals 0, which is what we wanted to happen. And from this, now we can see the values of a, b is here in the middle, and c is at the end. So you see b is the coefficient in front of x, which would be a minus 1 here. So if it helps you, you can list these values to the side that you're about to use. So a is 2, b is -1, c is -4. And then all we have to do is set up our formula and substitute. So again, that formula here is x equals, it's good to write that down to remind yourself what you're finding. And we have negative b plus or minus the square root of quite a bit. So there's a lot under the square root. So make sure all this is underneath here. B squared minus 4ac all divided by 2 times a. So everywhere that we have the letter a here, we're going to substitute it with, replace it with the letter number 2. Anywhere we have the letter b, we'll replace it with the value of -1. And the one place we have the letter c, we'll replace with a -4. So also keep in mind that we really need to pay attention to the signs that we have. That can have a huge effect on what happens. So in our formula here, we're going to go ahead and substitute. We have x equals negative, and then our b value is a -1. So here we get a negative, double negative, plus or minus the square root of b squared. So we have -1 squared, and if you're typing this into the calculator, make sure you're using parentheses around your -1. Minus 4 times a is 2 times c, which is -4. And again, all being divided by 2 times a, which is 2 times 2. So a very large fraction bar to keep track of there. Okay, so we rewrote our equation so it equals 0. We had our formula ready to go, and we replaced everything with the values that we had for a, b, and c. From here on, all we need to be able to do is simplify. So let me just give you some tips and strategies here. Simplify this first part. Minus negative, we know it just means positive, so we get a +1 in the beginning. And then you really want to make sure you simplify under the square root. That's going to have a huge effect on the solutions that we get. So you could pull out a calculator such as Desmos scientific calculator and type in all of this at one time. I would not, however, recommend typing in the square root into Desmos. I would just figure out the value that you get underneath before you go any further. So if we were to type all this in, this is -1 squared minus 4 times 2 times -4. I'll do that separately here first, just in case. If you are doing it separately, you'll get a 1 there. And then this is a -4 times 2 times a -4, which is going to give us positive 32. So I'm going to work that separately here, simplify it in separate steps, but in future, I'm just going to use Desmos to get that for me, or some other calculator. Our denominator is 2 times 2, which is 4, and we are getting very close to finishing this. We just need to simplify underneath that square root, and we get 1 plus or minus the square root of 33 over 4. And we ask ourselves, well, what do we do here? Things we should ask ourselves are, do we know the square root of 33? If we do, we should calculate that. If not, we actually are going to finish from here. This is our final solution. 1 plus or minus the square root of 33 over 4. And it's okay to write it this way. It's actually pretty standard, but it's kind of hard to see for some of us that we have two solutions. So if you need to see those two solutions, what you can do is you can write this separately. Not that you have to, but the two separate solutions are going to be these values. Just one, in one scenario, we'll use the plus and the fraction. So we have 1 plus the square root of 33 over 4. And in the other scenario, we will use the minus sign, and we'll get 1 minus the square root of 33 over 4. And so that would be the two separate solutions we'd have from this equation. And we get our two different answers because we're adding and subtracting. Okay, so pretty basic. It should look very familiar to what you've done in the past. And it is, and it's still finding the x-intercepts. So on number 2 here, we're already set up equal to 0. And so we should be able to see that A is equal to 3, B is equal to 2, and C equals -1. And so as we set up our formula here, we have x equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. We'll substitute, and it's a good strategy to use parentheses when you substitute. So we get minus, and b is 2, and then plus or minus the square root of 2 squared minus 4 times 3 times -1. Keep track of these signs here. And we're going to divide by 2 times a, which is 2 times 3. Okay, so now it's just a simplification process again. We get x equals, that's -2 plus or minus. And again, let's figure out what's underneath this square root sign. And rather than working it separately, I'm going to simply type in this expression underneath it, the 2 squared minus 4 times 3 times -1. I'm going to type in all of that at one time into my calculator, and I should see that I end up getting 16 here. Okay. And then underneath the fraction bar, we have 2 times 3, which is 6. Okay, and we have a little more simplification to do this time around because we know the square root of 16, right? So to simplify this, we take the square root of 16, and we get -2 plus or minus 4, which is the square root of 16, divided by 6. And then we want to get our two separate solutions. We want to know what they are, and it's very easy. From here, you just split into two separate fractions. So we have x equals -2 plus 4 divided by 6. And then we also have -2 minus 4 divided by 6. And to simplify these, we add in the top of our fraction first. So here we get x equals 2 over 6, which reduces to 1/3. And over here, when we subtract in the numerator, we get x equals -6 over 6, which simplifies to just -1. And so we have our two solutions just like we should be getting. And again, we should always get two solutions with quadratic equations. So in this scenario, our two solutions are -1 and +1/3. And just kind of a reminder to you, when we are doing this, and I know I said it earlier, but let's recap that one more time. When we are doing this, we are finding the x-intercepts on the graph of the parabola. And so what we would see is if we were to graph the equation that we had in number 2, this 3x squared plus 2x minus 1, we would see that it crosses the x-axis at -1 as well as +1/3. So far we've seen a case where we have two solutions where there's still a square root remaining, and a case where we have two solutions and the square root had disappeared because we were able to evaluate it. So looking at two more scenarios here, in the essence of time, I've already started them for us. We still always want to make sure that we are rewriting equations when needed. And so this first equation here says equals -4. We want it to equal 0. So we're going to rewrite this by adding 4 on both sides. And we'll get 9x squared plus 12x plus 4 equals 0. And so that would tell us that A is equal to 9, B is equal to 12, and C equals +4. And it's very important that we did this because if we hadn't added the 4 on both sides, we might have been tempted to say that C was equal to -4, which would give you an entirely different solution in the end. So always be careful in your process. But now that it equals 0 and you know A, B, and C, you just substitute into the formula, which I have done already. And we just need to simplify it from here. So we see in the beginning, we have a -12 plus or minus the square root. And again, let's type all of this in at once into our calculator, not the square root sign. And we end up getting a value of 0. Okay, so that can happen. We're going to see what happens because of that. And we need to divide by 2 times 9, which is 18. And so simplifying this, we get -12 plus or minus. And we don't think about it often, but we actually know the square root of 0 because square root means something times itself. That would give you this value. And 0 times itself is 0. So we can take the square root of 0. It is just 0. And we divide by 18 here. And there's a couple ways to reason through this. Maybe you realize that adding and subtracting 0 has the same effect. So we won't actually see different things happen here. Or maybe you realize that plus or minus means to add in one case and subtract in the other. So if we take that approach where we add in one setup and we subtract in the other, we'll end up finding our two solutions. What happens though is here we add 0 and get -12 over 18, which reduces to -2/3. And in this other setup, we have -12 minus 0, which still gives us -12 over 18, and that also reduces to -2/3. Now, I like showing this because we clearly see that we found two solutions. We solved two equations to get these solutions, which we want to always have. However, sometimes those solutions are the same. And when we have repeated solutions, we don't list them twice in our solution set. We just say that we have a solution of -2/3. Keeping in mind that this means that your parabola only has one x-intercept. We saw this happen last time as well. Because you only have one x-intercept, that would mean that the vertex of our parabola is the x-intercept. That is the only way we could only have one x-intercept on this graph. Okay, so far we've seen a scenario where we have two solutions where we might have a square root in it or it might simplify. And we've seen a case where we just get one solution. And what we haven't talked about in a while is these imaginary solutions that we know should exist because we've discussed imaginary numbers. And so we're going to take a look at number 4 here. You see that it already equals 0. And we can see that A is 2, B is -8, and C is 26. And you might also notice that all of our terms are divisible by 2. And in terms of factoring, that could help you to divide by 2 before you get started. However, quadratic formula, and because we have calculators, it doesn't matter if we're using the numbers that were given or reduced values because it's all going to work out the same in the end anyway. So I just kept it all the same. I used our quadratic formula here, substituted all of our values. We do need to simplify this. And so if we do that, we get x equals +8, this minus negative, and then we have plus or minus the square root of. And what happens here is very interesting. So again, be careful. Don't type in the square root, just this expression underneath it into your calculator. And you'll notice that we get a value of -144, which is kind of a big deal. And let's see what we get underneath this denominator. In the denominator, we have 2 times 2 equals 4. So we still need to simplify this, and you see that we're taking the square root of a negative. However, you also see that 144 is a number we know the square root of. And so if you recall, taking the square root of 144 and the square root of -144 are both going to give you a result of 12. The only difference is when you take square roots of negatives, you get imaginary values. And so is the square root of 144 12? Yes. But when you take the square root of -144, it's going to be imaginary. So we get 12i in this scenario. And then underneath we have this 4. So you notice that we took the square root. We have imaginary involved, yes, but we've taken the square root, and now we're able to simplify our answer because there's no square root remaining. And so we have 8 plus or minus 12i over 4. We can't add the 8 with the 12i. They are not common terms. But what we can do is look at those two terms separately. And so we could, in terms of simplifying, rewrite this as 8 over 4 plus or minus 12i over 4. Because both of these terms were over 4, and we can either look at them together or look at them separately. And if we look at them separately, we can reduce. We know that 8 divided by 4 is 2. And we have plus or minus here. 12i divided by 4 is 3i. And it's actually okay to leave our answer like this. We have two solutions. We have 2 plus 3i and 2 minus 3i. However, if you prefer to see your two answers separately, knowing that you're supposed to have two separate solutions, you may choose to write this as those two values, 2 minus 3i. We don't know what that is. It's an imaginary value. And 2 plus 3i, that does not simplify any further, but there are the two solutions shown separately if we choose. But again, it's okay to just write this as your solution, the 2 plus or minus 3i. And that's as complicated as the quadratic formula is going to get for us. It's a very handy tool in terms of needing to know what our solutions are, especially if we want to know what exact solutions are, instead of decimal approximations that we might see on a graphing calculator. So just one last bit here to tie in what we've talked about. We hopefully know that these equations that have x squared, these quadratic equations, have two solutions. And so what could happen is you could either have, as we've seen, one solution. And we have a name for that. When you just have one solution, but you know you're supposed to have two, that happens right here in number 3 when you have the same solution twice. And so when we get that same solution twice, we call it a double root. And that's what you see right here. So a double root describes when you have the same two of the same value for your solution. Okay, so we could have one solution. We could have two solutions. So that would mean that we have two x-intercepts on our graph. Or it is also possible, like we just saw in the last case, to have two complex roots. And I'm going to put complex because that's very common to say it that way. But also remind you that complex means imaginary. So down here you see three graphs. Hopefully you see the y-axis and x-axis in each one. Just kind of showing you when we have two, one, or imaginary solutions, you find your x-intercepts. So this first graph here has just one x-intercept. That would be a case of a double root. We see, let's go to the last scenario. We see a graph that has two x-intercepts right here. This would be a case of two solutions, and we could put that they're real. Generally, we assume that they're real. So that would be a case of two real solutions because you see that we're crossing the x-axis twice. And then in the times where we don't cross the x-axis, but we know we're supposed to have two solutions still, that would be a time where we would say two complex solutions. Because there are no x-intercepts. Okay, and I hope that has helped refresh you on how this formula works, and hopefully we can use this in the future to help us analyze our graphs as we go.